Welcome to the Shikasa Boo Motor channel. This channel provides easy-to-understand explanations of car mechanisms. This is a saying by an ancient Chinese philosopher, and it means, too much is as bad as too little. Dongfeng Motor is a state-owned automobile manufacturer in China. According to a Reuters report, its passenger car sales in 2024 were 1.54 million units, so it is not a particularly large automaker. They have equipped their SUV, the Mage, with a newly developed hybrid system called DHI. In general, hybrid systems are classified into power split, series, and parallel configurations. Power split hybrids are used mainly by Toyota, series hybrids primarily by Nissan, parallel hybrids largely by European manufacturers, and series parallel hybrids, which combine series and parallel architectures, are mainly adopted by Honda and BYD. Dongfeng Motor's new system combines a power split, a series, a parallel, and a 4-speed transmission. In this video, we will explore the system configuration and operation of this highly complex system. To understand Dongfeng's system, we will briefly learn about power split hybrids and series parallel hybrids. If you're already familiar with hybrid systems, please use the seek bar to skip to the next chapter. If you'd like to learn more about these hybrid systems, please check out these videos. There are links in the description. A power split hybrid consists of an engine, a generator, a planetary gear set, and a traction motor. In engine drive mode, the planetary gear set functions as a CVT, continuously variable transmission, allowing the vehicle to change speed while maintaining the engine in its high-efficiency operating range. Let's take a look at how the shifting works. In Toyota's system, the planetary carrier is connected to the engine, the sun gear to the generator, and the ring gear to the wheels. The gear ratio is controlled by the load applied to the generator. In other words, adjusting the generator's output controls the gear ratio. When the system controls the generator to produce maximum power, the generator's rotational resistance also reaches its maximum. As a result, the sun gear rotates at a lower speed, while the ring gear and the wheels rotate at higher speeds. This corresponds to a high gear ratio. When the power generation is reduced, the resistance produced by the generator decreases, allowing the sun gear to rotate faster. While the engine and planetary carrier maintain a constant rotational speed, the ring gear's rotational speed decreases. This corresponds to a low gear ratio. This mechanism enables Toyota's system to achieve exceptionally high fuel efficiency. Series parallel hybrids consist of an engine, a generator, a traction motor, and a clutch. In series hybrid mode, the engine drives the generator, and the electricity produced is used to operate the traction motor to propel the vehicle. The clutch is disengaged, and the engine is not involved in propelling the vehicle. When cruising at a constant speed on the highway, the system switches to engine direct mode. In the mid-rotational speed range, the efficiency of the electric motor decreases, while the efficiency of the engine increases. The clutch is engaged, and the engine directly drives the wheels. When strong acceleration is required in this condition, the system switches to parallel hybrid mode. Battery power is supplied to the traction motor, and the vehicle accelerates through the combined torque of the engine and the traction motor. Now, let's take a look at the configuration of the world's most complex hybrid system. Clutch 1 is positioned on the engine's output shaft. The engine is a 1.5-liter turbocharged inline-4. The self-charging hybrid model delivers a maximum output of 145 kilowatts and a maximum torque of 305 Newton meters. while the plug-in hybrid model delivers 113 kilowatts and 240 Newton meters. The shaft of clutch 1 is connected to the ring gear of the planetary gear set. Clutch 2 is positioned between clutch 1 and the ring gear. The outer case of clutch 2 is integrated with the transmission case, and when it engages, it locks the ring gear. A hollow shaft is connected to the planetary carrier. The sun gear shaft passes through the inside of the planetary carrier shaft and is connected to the generator. A two-speed shift mechanism 2 is integrated into the planetary carrier shaft. A two-speed shift mechanism 1 is also integrated into the traction motor shaft, and its gears mesh with those of shift mechanism 2. In the self-charging hybrid model, the traction motor delivers a maximum output of 105 kilowatts and a maximum torque of 210 Newton meters. In the plug-in hybrid model, it delivers a maximum output of 100 kilowatts and a maximum torque of 260 Newton meters. A shift mechanism 3 is integrated into the rear end of the planetary carrier shaft. This shift mechanism switches among three modes, connecting the planetary carrier shaft and the sun gear shaft, locking the planetary carrier shaft, and letting both shafts rotate freely. Power is transmitted from the gears of shift mechanism 2 to the differential via the output shaft. In EV mode first gear, the engine is shut off, clutch 1 and clutch 2 are disengaged, shift mechanism 1 engages its low gear, and shift mechanism 2 and 3 are in neutral. The traction motor's output is delivered with a large reduction ratio. When shift mechanism 1 shifts into high gear, the system switches to EV mode second gear. As shown in this graph, the efficiency of the electric motor decreases as its rotational speed increases. To prevent this, equipping the vehicle with a shift mechanism that can maintain a low motor rotational speed even at high vehicle speeds is effective. In fact, some battery EVs, such as the Porsche Taycan and Audi e-tron GT, are equipped with a two-speed transmission. In addition, many Chinese manufacturers' series parallel hybrid systems are also equipped with 2 to 3-speed transmissions. When shift mechanisms 1 and 2 engage the low gears, shift mechanism 3 connects the planetary carrier shaft and the sun gear shaft, and battery power is supplied to operate the generator as a drive motor. The system switches to EV dual mode first gear. This table shows the traction motor outputs of the Dongfeng Mage, the self-charging hybrid Honda CR-V, and the plug-in hybrid BYD Sea Lion 6. Compared with the other two vehicles, it is clear that Dongfeng's traction motor output is lower. Since Honda's and BYD systems are simple series parallel hybrids, the engine and generator cannot be decoupled. In contrast, Dongfeng's system can disconnect the engine from the powertrain via clutch 1, allowing the generator to be used as a traction motor. This makes it possible to use a lower output traction motor. By engaging shift mechanisms 1 and 2 in the high gears, the system switches to EV dual mode second gear. In series hybrid mode first gear, shift mechanism 1 engages the low gear, shift mechanism 3 connects the planetary carrier shaft and the sun gear shaft, and clutch 1 is engaged. The engine drives the generator through the planetary gear set. The generated electricity powers the drive motor, propelling the vehicle. The engine is not involved in propelling the vehicle. When shift mechanism 1 engages the high gear, the system switches to series hybrid mode second gear. In engine direct mode first gear, clutch 1 is engaged, shift mechanism 2 engages the low gear, and shift mechanism 3 locks the sun gear shaft. The engine speed is first reduced by the planetary gear set, then stepped up by shift mechanism 2 before being transmitted to the differential. When shift mechanism 2 engages the high gear, the system switches into engine direct mode second gear. In engine direct mode third gear, Clutch 1 is engaged, shift mechanism 2 engages the low gear, and shift mechanism 3 connects the planetary carrier shaft and the sun gear shaft. The engine speed passes through the planetary gear set without being reduced, then is stepped up by shift mechanism 2 before being transmitted to the differential. When shift mechanism 2 engages the high gear, the system switches into engine direct mode 4th gear. When the traction motor is activated in engine direct mode, the engine output and the traction motor output are combined, switching the system into parallel mode. Parallel hybrid mode 1st gear. Parallel hybrid mode 2nd gear. Parallel hybrid mode 3rd gear. Parallel hybrid mode 4th gear. In power split hybrid mode, the vehicle speed is varied by adjusting the generator load while maintaining the engine speed constant. At low speeds, the system increases the generator load to reduce the sun gear speed. The planetary carrier speed is greatly reduced relative to the engine speed. Battery power is supplied to the traction motor, and the engine output and traction motor output are combined to propel the vehicle. When the system reduces the generator load, the sun gear speed increases, causing the planetary carrier speed to rise as well. As a result, the vehicle speed increases while the engine speed remains constant. Furthermore, in this system, after the continuously variable speed change produced by the planetary gear set, shift mechanisms 1 and 2 allow for 2-speed shifting. Since documentation on the regenerative braking control could not be found, the explanation from this point onward is an educated guess based on mechanical principles. Please keep this in mind. In the weak regeneration mode, shift mechanism 1 engages the high gear. The rotation of the wheels is transmitted to the traction motor, which then operates as a generator, providing braking force while charging the battery. When shift mechanism 1 is engaged into the low gear, the regeneration mode switches to strong. Due to the large speed increasing ratio, the traction motor reaches a higher rotational speed, resulting in stronger braking force and greater power generation. When clutch 2 is engaged, the ring gear is locked. Engaging shift mechanism 2 transmits the wheel rotation not only to the traction motor, but also to the generator, allowing the system to produce even greater regenerative braking force. As mentioned earlier, the description of the regeneration control is based on assumptions. It is unclear whether the actual system operates in this manner. According to Dongfeng, this system has as many as 26 modes. If this complex control is achieved without any delay, shock, or discomfort noticeable to the driver, we should commend the development team for their accomplishment. Nissan's hybrid system is among the simplest hybrid systems in the world. It adopts a series hybrid architecture and consists only of a traction motor and a generator, with no shift mechanisms, no clutches, and no planetary gears. Needless to say, the only driving mode it has is the series hybrid mode. Whether in urban areas, in suburban conditions, or on the highway, the engine drives the generator, and the electricity it produces powers the traction motor to propel the vehicle. Then, there's no way it can deliver good fuel economy. This is a fuel economy comparison between the UK spec Nissan Qashqai and the Toyota Corolla, which has a similar vehicle weight. This channel does not have real-world fuel economy data for these vehicles, but at the very least, in terms of WLTP fuel economy, Nissan outperforms Toyota. Even a simple hybrid system like Nissan's may be capable of achieving sufficiently good fuel economy. Let's compare Dongfeng's system with Nissan's. It's hard not to be reminded of the saying, too much is as bad as too little. Thank you for watching. If you enjoyed this video, please consider subscribing to the channel. We'll see you in the next video.